All right, let's go talk about the number e and continuous compounding. We've already said that e is an irrational number, and it was approximately equal to 2.71828, correct? And I told you there's two places on the calculator to find it. It's either second, the division sign, or second, the ln button. One of them, the division sign gave you just the e, and the second ln gave you e to the power of. And so you'd have to type in a 1. All right. Your second formula that you need to commit to memory is A equals P e to the RT. A lot of students call that PERT. How do you know to use PERT? In your problem, you will see that it is compounded continuously. Continuously means PERT. Again, the interest rate has to be a decimal and the time has to be in years. Let's go do an example. How much money would you have after 5 years if you deposited $5,000 into an account paying 3% interest compounded continuously? What formula do you use? PERT. A equals P e to the RT. What is P? 5,000. E, interest rate, 0.03. And for time you do, time is 5. On your calculator, you can just type in 5,000 E caret 0.03 times 5. $5,809.17. Is that what this one had? Yep. 5,809.17. Questions? Someone yesterday asked, 5,000 E, is that a times there? Yes. It's 5,000 times E. But your calculator knows to do that. Okay, last problem. You want $1,000 invested for 10 years at an account paying 4% interest compounded blank. And I told you annually, semi-annually, all the way up to continuously. The only one that uses the PERT formula is what? Continuously. So this is going to be A equals PERT. What is the formula? What are you going to type in? You're going to do P e to the R T. What do you get on that one? 1,000 E to the R. What was it? 4%? For how many years? 10? 1491.82. Okay, I didn't want to type that formula in 1,000 different times. Your formula would be 1,000 1 plus 0.04. For annual, it would be over 1 times 10. If you notice, those two are the numbers that are changing, right? So on my calculator, I typed in the equation and put an X on the two places where the number is going to change. Then I went over to my table set and I said, let me type in the independent variable X and let it automatically spit out the Y's. I went and looked at my table and I typed in the different X values that spit out the different Y's. If I only compound it one time a year, I get $1,480. If I compound it continuously, how much did I get? $1,491. So from 80 to 91, is that really all that much money? It's not that much money when you're only talking about $1,000 investment. What if you're talking about a $1 million investment, or you're a bank and you have to pay out that interest to people, and you're paying out money on $1 billion? Do you want to compound it annually if you're having to pay out? Or are you going to want to compound continuously? I think bank accounts, savings accounts pay out quarterly. Is that right? Most of the time? At your 0.2% interest? So if you're interested in that stuff, go take a finance class. Otherwise, I'll see you guys on Thursday.